Hello, YouTube viewers. Welcome to my show, Rocket Monday. In today's episode, we're going to talk about SpaceX Starhopper. So let's dive right into it. Now, first thing you have to understand, basically, this Starship is basically a very big project. You have to understand it in this way. The biggest diameter of basically Falcon 9, basically Falcon 9, because Falcon Heavy is just two more added onto it, is under 4 meter. It's basically 3.4 meter. The reason why that diameter was specifically chosen is that SpaceX is not a big company. So they cannot have the luxury of using a different road or custom built road or things of that nature. So they designed the whole system to be transported using road infrastructure. Road infrastructure have a clearance of 4 meters, so they built something smaller than that, and benefit of that, they can just build whatever wherever they want, and they can transport it. This time they're going big. They're going upwards of 9 meter. They may even change it in the final design, but you have to understand this is a big thing. And due to continuous upgrades that people did to Merlin engine has reached its maximum point. Basically, at this point, even their theoretical model is like, yeah, you can barely extract bit more power out of it. Do not expect like, okay, we went from same way the original was only capable of 10 ton to low earth orbit. Now they are capable of 20 tons, but you cannot expect that jump again. Basically, at best, you can do 20 ton to 22 tons. So you have to understand this, like that engine has been maxed out, and they don't want to tamper too much with it because that engine has been qualified as what we call design freeze. So it can be used for manned missions. So they don't want to tamper with it, and they cannot tamper with it, so they are like moving to the next generation. The next engine is Raptor rocket engines. Now that's a completely different ball game. Raptor rocket engines is like one of the most complicated engine ever built. So that is the whole idea. They need to test Raptor and SpaceX next chip design. So there are a lot of information is on the line. So they have to test it, and this test bed is like for them. Like this is, of course, they cannot directly build this. They have to do the test bed, and this was the whole project of it. That's why this was built so cheaply with normal steel and all that. So what was the procedure for something like this? Well, procedure is very simple. You have your stuff, you quarantine the whole damn area. Basically, this whole area was quarantined, and I mean hard quarantine, because it was an untested system. So from flight controls to road seal off to sea traffic, everything was diverted or flat out stopped, and then they did that system test and all that. And government required them to have on hand $100 million as an insurance money, and they had to had it. It's not, it cannot be like, okay, if something goes wrong, then we will bring 100 million. You have to have 100 million now. So if something goes wrong, you should be able to quickly respond. So these procedures were big and expensive, and that's why they could not just, even if the construction was done months ahead of schedule, they could not test it, because all of these things have to be scheduled also. So you can understand it's quite complicated procedure. So what happened? Like they did the procedure, they tested it. So test was limited to 150 meter in height. Now again, this is a complicated thing you have to understand from FAA standpoint of view, because this is an untested structure. They do not know what happens if it explodes or not. So 150 meter was a ceiling. Again, as they will keep proving on it, SpaceX have to prove it. Like, okay, I can go to 150 meter, I can go to 500 meter, I can go to 1 kilometer, I have to go to 5 kilometer. Like it's a testing kind of scenario. So if what happens if they exceed it? Let's say for some reason, because it has a lot of torque and propulsion and all that, it can go much higher. So instead of, let's say for some reason the software malfunctions and the engine goes to full throttle, and it will go much higher. Like I think it could have easily reached to 1 to 2 kilometer, but that caused the problem. Like then it can fall very far apart. So in those sort of scenario, if they had exceeded 150 meter, they would have to detonate the basically craft itself. So that did not happen. They can properly reach the 150 meters and hovered around there as they wanted to. They demonstrated ability to using gas thrusters to turn and twist basically. And the target duration was 1 minute. They achieved 57.36 seconds. So quite awesome. And the amount of fuel they were carrying was 30 tons. Now 30 ton of fuel may seem too much, and yes, it is too much for almost any rocket, but for something this big, it's a chump change. So that was the test. They successfully reached 150 meter. They successfully did the duration also, and they burned most of the fuel. Okay, that was the test. So what is the result? What is the final outcome? Now you have to understand this. This was not done for the first time. This was done. You can quote unquote say third time, because they have done the engine firing test. This was the moment they wanted to do the original 150-meter hop test. The engine malfunctioned. Basically, the engine ignition system is different here than it is in Merlin system. Merlin has a third-party igniter. Basically, they will have liquid kerosene and liquid oxygen, and then they will have a third fuel that is like quote unquote pyrotic charge, and that will go there and ignite it on contact. So nothing fancy involved. Side effect, it runs out. Like they have to make sure that there is another third fuel tank with all that jazz. So this time they are going with simpler system, which was used in space shuttle engines, which we call basically ignition chamber of basically spark plug. It's like an electrical spark plug system. So they're not going to run out of electricity, so they can reignite the engine as many times as they want to. That failed. They have two independent ignition systems. Both of them failed. Again, if they are lucky, it was just like some normal manufacturer. If unlucky, they had to redesign the whole system. So that failed. Then they postponed the testing system. Then again they did it. The second time it was successful. Everything was awesome. And the landing, like they go up, they hovered around and then landed. The landing was a bit rougher than expected, because all the landing legs have crush systems into that. They're not supposed to be crushed all the way, but it got crushed in. So but again, it was designed for that. Like it's a test system, it meant to take some beating. So the landing was a bit rougher than expected. And one of the pressure vessels, basically the cold gas thrusters have a lot of pressure vessels, ran away. Basically you can check the videos I have provided in down below. Like one of the pressure vessels, whee, it runs away. Now at the first glance, everybody thinks like, hey, bit rough, everything is awesome. But at a closer look, once people got much higher quality footage and all that, they realized something was wrong with the engine, because engine is running basically liquid fuel. It's not running heavy fuel. Basically, like RP1 is a heavy fuel, so exhaust of RP1 is a bit yellow. But if you are running something light fuel, like let's say hydrogen, your exhaust will be transparent. So if you are burning something like methane, your exhaust should be light pink, basically barely visible. It should be barely visible. Again, the reason you can see that is shock diamonds, not the exhaust itself. You can see the shock diamond very easily. So this was happening, everything was on, but during landing something changed and it started to go yellow. Now there is nothing in the fuel system that could cause it to go yellow this much. Again, if this whole area becomes yellow because there is like particle glowing into what we call black body radiation, awesome. But this whole exhaust became yellow. So there, some people are suggesting something malfunction happened, and that could be the reason why the landing was so rough, because everything was working. Like hovering a rocket engine is very difficult, and they successfully did that, but somehow landing wasn't wasn't smooth. So something happened. And if you are following with SpaceX news constantly, you must be aware like one of the Raptor engines had a turbine failure. So again, something like that may have happened, or something very minimal, like a small metal block might have been charred, and that would have been coloring the exhaust, because this is not the color that is supposed to be. So something is iffy there. Now thankfully engine did not explode, so everything is awesome, and I'm pretty sure there's some minor issue, otherwise it would have gone boom. So results were quite good, positive, encouraging. So what does this mean for the future? Well, we need more testing. Now you have to understand this way. This is a completely untested waters, because you can look into Merlin engine and be like, hey, I think this design is based on this Russian concept, this NASA engineering and all that. There is enough data there to be like, okay, they took the knowledge from these system and built a better system. Here there is nothing. There is no system that comes even close to the system. It's a completely closed loop. Basically there is no exhaust from the gas generator. If you have looked at closely the Merlin engine, it has a small nozzle that has very sooty kind of output, that is from the gas generator. Now what in space shuttle engine, there was no exhaust like that. Here also is the same. Only difference is the basically space shuttle engine, which was one of the most complex engine till that point, had basically one gas generator. Basically they will have a little bit of fuel or little bit of oxygen. Basically one would be always less. You could have too much fuel or too much basically oxidizer, so you will burn colder. If you have too much oxygen, you will burn colder. If you have too much fuel, you will burn colder, because there won't be enough to do maximum chemical reaction. Benefit of that, instead of metal melting temperature of 3000 degrees Celsius, you will be like around 1500 degrees Celsius, and that quote unquote partially burned exhaust will be sent back to the engine again, and using the main energy that you got by burning it, you will turn the turbine. Here they are doing the same thing. Only difference is there is now two gas generators. Benefit, they can independently control the system, and because the gas generator is working a bit more differently. I'll make a complete detailed video about this. Working a bit more differently, it should last longer. You have to understand, till this point SpaceX barely exceeded a point where they can say like this engine has been reused 10 times. and inherently they cannot do that. Like something will break in the engine is inherently not that stable. So this whole design, the whole reason why they are building the Raptor is to make that inherent limitation go away. So the target is like bare minimum 25. So you have to understand, right now they haven't reached even 10, and this whole new design, the why they are redesigning is basically so they can reach up to 25 at bare minimum. Again, they are saying we can do 100. Let's see. Of course, more testing is needed. So Raptor is a go. So because you have to understand, firing Raptor engine at test bed is a very vibration intensive experience, but when you are launching it, it's completely different ball game. So this was the first time they actually launched it, and it's a completely different experience. And you can see this is how the exhaust is supposed to be if it's that close to the ground. It's supposed to be completely pink or a little bit of yellow, not that yellow. So Raptor is a go. Everything is awesome. Raptor is a go. Then Starship is also a go, because you have to understand that is why they were demonstrating the coal gas thrusters also, because engine is will not be powerful enough unless like you have 3 to 4. During launch they don't have to worry about, but during landing they have to worry about this, because during launch they will have more than enough engines to control properly, but during landing they will only have enough fuel for 3 engines. So that is why like they had to test this cold gas system and all that. So that's also a good to go, but it will take time. You have to understand, this is Elon Musk time of like in 2 years basically. 2021 they will have the Starship ready. Yeah, no, not that's not gonna happen, but things are looking up. Like this is a research, this is development, this is how it's done. They went back to the drawing board, they designed the most advanced engine out there, and it is working. Like as of now it is working. It did not blow up, it worked as it's supposed to do. It had more than enough thrust, so everything is good. Again, they have to refine it. It's a rocket engine, this is a complicated thing. So the future of SpaceX is looking up right now. So this was my presentation on Starhopper test. I hope you learned from it. In that case, please click the like button. If you didn't like it, didn't enjoy it, I would urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.